This lesson is about comparing sets of data by looking at measures of dispersion, in other words, how spread out the data is. If we take this example where a greenhouse needs to be kept at a temperature of 25 degrees Celsius, the gardener buys 2 heaters and tests them in 2 different greenhouses. Before we go any further, I'd like you to pause the video and calculate the mean, median and mode of these 2 data sets to see which you think the gardener should choose, bearing in mind the temperature is supposed to stay at 25 degrees Celsius. Hopefully, if you've carried out those calculations correctly, you found that the mean for both greenhouse A and greenhouse B was 25 degrees Celsius. But looking at the data, you should also see that although the means are the same, one of the greenhouses maintains a more consistent temperature than the other. And the way we can check this mathematically is to look at how much each value deviates from the mean. And to do that, we subtract the mean from each of the individual values. So in greenhouse A, the deviation from the mean ranges from -4 to +4, and in greenhouse B, the deviation from the mean ranges from -1 to +1. Now, just as with measures of central tendency, the mean, the median and the mode, we're looking for a single value which typifies the data. When we're describing the spread of the data, we're also looking for a single value which summarises these deviations of scores from the mean. The range is the maximum value subtract the minimum value. So for greenhouse A, this is 8 degrees Celsius, and for greenhouse B, it is 2 degrees Celsius. But the problem with the range is that it only takes into account 2 of the original scores, the highest one and the lowest one. These may be outliers and not typical of the data, so the range is of limited use. Another option is to sum the deviations for each set of data. So for greenhouse A, if we add up all of the deviations from the mean, and then do the same for greenhouse B, can you see why this might be a problem? Well, by their very nature, the deviations from the mean, when you add them up, sum to 0. So this is not a very helpful operation to perform. Another possibility is to ignore the negatives and then find the average deviation for each greenhouse. For greenhouse A, this is 16/8, which is 2, and for greenhouse B, this is 2/8, or 0.25. Now this is called the mean deviation, and it is sometimes used. But a far more common measure of spread is called the standard deviation. And the symbol for standard deviation is this lowercase sigma. Now, to work out the standard deviation manually, as we're about to do, is more complicated than the mean deviation which we've just done. Instead of just ignoring the negatives, square each of the standard deviations. We then find the average of these squares, which is called the variance, and then the standard deviation is the square root of the variance, and that's why the symbol for variance is sigma squared. The reasons for using the standard deviation rather than the mean deviation we won't go into here. They'll become more apparent in your future study of mathematics. But for now we'll just demonstrate how to calculate the standard deviation for the 2 sets of data we've been working with so far. Firstly, we need to find the sum of the squares of the deviations. So we take each of those deviations, square them and add them up. Then to find the variance, we divide that total by the number of scores, which is 8, to give a variance of 7.25. Finally, the standard deviation is the square root of the variance, so the square root of 7.25 is 2.7, and that's been rounded to 1 decimal place. Now I'd like you to pause the video for a moment and work out the standard deviation for greenhouse B before you watch my solution. So again, we square each of the deviations and add them up. We divide this by the number of scores to find the average of the squares of the deviations, also called the variance, and to find the standard deviation, we square root the variance to give a standard deviation of 0.5. So in conclusion, we have two greenhouses, A and B. Both maintain a mean temperature of 25 degrees Celsius, but greenhouse A had a standard deviation of 2.7 and greenhouse B had a standard deviation of 0.5. Therefore, what we can say is that although both greenhouses maintained the same average temperature, greenhouse B was more consistent than greenhouse A, or A had more variation in temperature than greenhouse B, and we can quote the standard deviation to mathematically support those conclusions. To conclude this lesson, I would like you to pause the video once again and calculate the range, variance and standard deviation for this set of data. Firstly, the range is the difference between the maximum value and the minimum value. So that's 16 take 5, which is 11. To work out the variance and the standard deviation, we first need to know the mean of the scores, which is 12. Next, we need to subtract the mean from each of the original scores to work out the deviations from the mean. And to check that we've done this correctly, these deviations should sum to 0. To work out the variance, we square each of the deviations, add them up and divide by the number of scores. So that's 10.2. And finally, the standard deviation is the square root of the variance, which is 3.19 to 2 decimal places.